So here's last night's homework. And as I said before, I kind of felt like you left without enough information to really get it done. So I'm going to cover what you need to know in order to do this Lewis dot diagram. Basically, a Lewis dot diagram is just a way to indicate the electrons in the outer shell, what's referred to as the valence electrons. So the valence shell is kind of like always the outer shell. No matter what the element is, it's always the outer one. So as an example, I started with sodium. And instead of drawing what we were doing before, we draw the protons and the neutrons, you actually get to just use the symbol. So that you've got the element symbol right here. And that represents like your nucleus or the atom itself. And then you're going to arrange the outer layer of electrons around the four sides of the symbol. So sodium is number 11 on the periodic table. It's number 11, which means it has 11 protons, and therefore it has 11 electrons. The first shell has 2 electrons. The second shell has 8 electrons. And if its third shell was full, which it's not, it would also have 8 electrons. One of the things I find helpful is a diagram that kind of puts the dots and the Bohr's model in a hybrid. Okay, so sodium here in this hybrid model of the Bohr's and the dots shows 11 electrons around the outside. And as you can see, this first shaded area represents that. Like I had drawn the line with the 2, showing there was 2 electrons in that nearest shell. And then the next energy level, the next valence outside of that would hold 8. So you've got 1, 2, 3, 4, 5, 6, 7, 8. And then in the third shell, around the very outside, there's just the 1 electron left over. Okay. So we are not concerned with the 2 that are full and the 8 that's full. We're only concerned with this outer shell. And the same goes, you can see, for potassium. That's what's going on. It's not this shell that's full and happy or this one that's full and happy that reacts with something. It's that outer shell that has a need for more electrons to make it stable. Okay, so the full shells are stable. And the ones that are not full are unstable, and they're going to react with things. And that's why molecules form, and that's why we're even concerned about this Lewis dot structure. This is the beginning of learning how to figure out what's going to bond with what. Okay, so when we go back to the notes, it's talking about sodium is number 11 on the periodic table. Its first shell holds 2, its second shell holds 8, so for a total of 10. And the third shell will hold 8, but in sodium there's only 1 in that third shell. And so you just draw 1 dot. Okay, and so where to draw the dots, you know, because there's a right and a wrong way to do it, right? You look at the atomic number and you figure out, you know, that like on sodium there's going to be 1 because the electrons will match the number of protons. There's going to be 1 in that outer one. It's like kind of like a remainder in division. It's like left out. Determine how many electrons are going to be in the outer shell. Simple subtraction, or this trick. You're going to look at the periodic table of elements, and I'm going to show you what you're going to be looking at there. You place dots evenly, kind of as far away from each other as possible, not on opposite, but you just rotate through. You place 1 dot at a time. Like say you start on the side and you place 1 dot and then another until you reach the number. Let's say there's 3 in the valence shell, then you just 1, 2, 3. If there's 6, you place 1, 2, 3, 4, 5, 6, going evenly around. So move and place 1 dot at a time, moving around the symbol. Okay, so here's the trick. Here's how valence electrons work. Here's how outer electrons work. They kind of line up. Okay, like I showed you with hydrogen, there's 1. Whoops. Hydrogen, there's 1. Lithium, there's 1 in the outer shell. Sodium, there's 1 in the outer shell. Potassium, there's only 1 in the outer shell. So all the 1s line up. So this first group right here, there's 1 electron in the valence shell. And then there's, in the next group, there's 2 electrons in the valence shell. Then we're going to do something where we're going to skip over all these middle elements. we're just going to go to the next one up here, next in line here. Kind of like what I showed you the other day with this bad boy right here, or with this one, okay? That is kind of smashed together. So we jump over to boron over here. There's 3 in the outer valence shell, 4, 5, 6, 7, and 8. Okay, so when I look at the periodic table, and I want you guys to switch over to your periodic table, find that bad boy, and we're gonna mark at the top of this which electrons, how many valence electrons there are for each of these groups. So it's actually marked for you, you're just gonna highlight it. So you're gonna go through and you highlight, there's 1 here, 2, and you can see the numbers already there on the periodic table that I gave you, 3, 4, 5 outer valence electrons, 6, 7, and 8. So if I'm asking you to do the valence electrons for, let's say, number 1, which is calcium, find calcium, it's in the second group, and I start here and I move around this way because I only have the 2 to worry about. Kind of think of this as like quadrants, 1, 2, and that's the dot structure for calcium. Potassium is in the first column, so it only has 1 valence electron. We kind of hash that out with this guy right here. You can start there and just put the 1 dot. Argon is different because argon is one of the happy gases, the inert gases. Its electron shell is completely full. It has 8 valence electrons, so I would start 1, 2, 3, going around, 4, 5, double up and pair that, 6, 7, and then 8, and that's argon. Aluminum is our next one, number 4. Aluminum is in the third column there. Not this column 3, but dealing with just those first 20 in the third column. So it has 3 electrons. So write the symbol. And then starting on the side, 1, 2, 3 electrons in that outer valence. Okay, so I want you to go ahead and try bromine. Okay, hopefully your dot structure on bromine looks like this. One thing I wanted to point out, that sometimes people want to line them up kind of like vertically, but this is not correct. Okay, so it's like the sides of a box. You line up the dots like kind of like a dot-to-dot box. And there's a space here, which means that bromine wants to gain an electron and it wants to bond with something else, and that is the dot structure. So you've got 6 through 10 to finish up, and then I will go over with the answers with you in class.